Hello everyone, this is Sachin again, and this time we are going to learn about a typical architecture in AWS. And as like my all other tutorials, it should be a matter of like checking out this code from Git repository and issue the command line program to basically spin the whole architecture using Terraform. So basically what I'm gonna do here is basically deploy using Terraform a basic typical architecture by segregating your public zones and private zones, and basically creating two different VPCs and stabilize the communication between VPCs using VPC peering. So I think this will help a guy working in AWS from beginner to intermediate level. Most of the time, like 10 years back when I was learning AWS, it was not quite obvious what is a VPC when I created my first EC2 instance. But I think it is important when we are working or creating an EC2 or like whatever we do there, we must be aware about how it communicates, how the machines communicate within VPCs, across VPC, or basically how they talk to internet. How do we segregate the public and private zones? Just look for look for Shukla GitHub repo. Just go to any one of the GitHub repository. Go back to SK Shukla in the main page, click on repositories and just search for sample AWS Terraform. Now this contains my project is already there in my IntelliJ. So basically these are nothing but Terraform scripts, and as long as you have Terraform installed, so Terraform version, as long as you have Terraform installed and AWS CLI setup in your system, you should be able to basically, it's just a matter of check out the project and execute the script which I will show. So Terraform is in my system, and if I say AWS S3LS, I want to list all my S3 bucket. Just grab something so it doesn't display all my S3 buckets. So all right, so once you have these two things set up, you're good to go. All right, so once you are in the repository, I just want to bring up the architecture what I'm going to implement over here. You just go inside source main Terraform and go inside 01 VPC peering. Here you will find all the code which is going to execute. All right, so this is the architecture we are going to implement, and here you will see the script will automate the whole process for you. I'm going to create two VPCs, and their CIDR is 12.1.0.0.16 and 12.2.0.0.16. So typically they can contain 2 to the power 16 IP addresses, but anyway, we are not going to use all of them. We're just going to create a public and private subnet in each of the VPC, as you can see here. So in 12.1 you will have a public subnet and a private subnet. In 12.2 you will have a public subnet and a private subnet. So public subnet, so what is a public subnet? I mean, as long as you associate an internet gateway to a subnet, that subnet becomes a public subnet, which means it can talk to internet, and a person, if the security rule allows, it can basically SSH or access any services and ports if they are open to this subnet. On contrary, the private subnet, you don't associate an internet gateway to the subnet, and that subnet becomes a private subnet, which means this guy from outside of a VPC cannot go inside that. So you can have kind of a bastion or jump host to basically to go to the, so these are like EC2, and this script will deploy this EC2 as well. So if you have to reach to a machine in a private subnet, of course you directly cannot go there. You have to go to a machine in a public subnet, and from there you can actually go into a private subnet machine. So so this is one thing, but we want to test a couple of things beyond just deploying it. Basically we will also be stabilizing a VPC peering between these two VPCs, which means let's say a machine in a private subnet can access a machine in private subnet of another VPC, and that's what you can see in this diagram depicted in the process tree. So the process symbol, I'll be associating into first VPC public EC2 instance. From there I'll SSH to a private subnet EC2 instance, and to showcase that VPC peering works, I'll be just pinging a machine in another EC2 instance in a private subnet in different VPC. So by default you won't be having access, but with the VPC peering this will allow it. Now one more important concept I want to cover about is a NAT gateway. So now you see the positioning of this internet gateway. This is deployed in a inside a VPC, but this NAT gateway, when you deploy, you have to tell which subnet you are going to deploy, and a NAT gateway must be in a public subnet, then only it can actually talk to the internet. So think about like a machine, let's say this EC2 instance, or you deploy a let's say manual database, and it needs to update itself, so it needs to communicate to internet sometimes, and the communication should start within this subnet, and it's not like from outside, and that's where we use NAT gateways. A machine in a private subnet can initiate the communication with internet. So it's typically like you want to ping a google.com, so you should be able to do in this private subnet. By default this is not enabled, and this is something which we don't know as a beginner level when we create an EC2 instance, and let's say the default route tables. I'll cover quickly what is a route table. The default VPC what AWS provides, and if you create an EC2 instance, by default it is able to access internet. But if you want to deploy this kind of an architecture, you want a fine-grained control like your own public subnet and private subnet, this by default the machine in private subnet cannot access internet. So basically you may go access inside it, but when you say ping google.com or whatever you want to access the website, this is not allowed, and that's where the NAT gateway comes into picture. So so how everything works is an instance in private subnet, so anything inside private subnet, if they needs to access internet, their route tables should be configured to for this communication. So how it works is when you deploy a route table, or like when you associate a route table with a private subnet, in this case you tell that for all 12.1.0.0 communication, you just go for your local, like within this VPC. If you want to access another VPC, and that's where you associate the object for this VPC peering. I will quickly cover it when we will be doing the demo. But if from this machine I want to talk to this machine, I need to tell that okay, this is the tunnel or VPC pairing you can use to communicate to machine over here. And now for all others like 0.0.0.0/0, it's like any IP address, just use this NAT gateway. Basically we will be creating a NAT instance, or sorry, NAT gateway, and in this route table we associate a NAT gateway, and most importantly, I repeat once again, this NAT must be in a public subnet, otherwise this communication won't work. And that's why you see in this architecture diagram, this NAT is deployed or associated into a public subnet. So I think the architecture is clear. So the objective is not much to cover what Terraform, how the Terraform scripts are written. You need not to know Terraform anything about it, as long as you have a Terraform installed, and you should be able to execute these scripts. Don't forget to adjust these properties according to your need. For example, this AMI image is a customized my image, but if you want to use a CentOS image, make sure you use the right region and subnet whatever inside them, and use whatever image you want to use. In my case, I'm using AP Southeast Asia 1 where I stay, and this image is a customized image, but you may go to this region, go to AMI images, find a right AMI image, just replace it over here, use your own key pair file, replace that over here, and that's all. Alright, so once you check out this project, basically this one over here, yeah, let me go up, yeah. So once you check out this project, you will see in the source main Terraform, inside this there will be two scripts, run bootstrap.sh, run teardown.sh. So I'll be using the bootstrap.sh. What's going to do here is just create everything for you. All right, so let me clear it. Let's go to my location, and in fact I can directly execute the bootstrap. Okay, before executing this one, you may see that, let me go to VPC, and I have only one VPC over here, which is the default one which comes with AWS. I'm in a Singapore region, and if you see my EC2, of course definitely there is nothing, no EC2 instance is running. And in fact I just quickly show it to you that there is no NAT gateway. Okay, this is deleted, this is from my previous demo, don't worry about it, just ignore it. Once I run this script, this will be again created. Internet gateway, I think, yeah, this is associated with the default VPC. And let me finally go to subnets, and you see I have existing 3 subnets which belongs to a default VPC. Alright, so let me execute it. Okay. So this takes a little time. Usually everything is real quick, except my observation. It takes a little time in creating this NAT gateway. So let's give it some time. I'll be pausing my video and resume it once this script is fully executed. Probably in my opinion should not be taking more than 5 to 8 minutes. Alright, I have resumed my video once again. Looks like it is almost close to completion. It created everything. Okay, perfect. So now this is created, and you can see that I'm outputting the public IP addresses for my 2 instances. Typically I'm outputting a public IP address for this EC2 in a VPC1 public subnet, and this EC2 which is in VPC2 public subnet. Alright, so let me go here. Still not refreshed my page. Let me refresh it. So now you see it's a more subnets are created. So I will get back to it, but let's go to VPC. So now you see there are 3 VPC created. Okay, they have the same name, but don't worry about it. You see one is created in 12.1.0.0.16 CIDR, and another one is created in 12.2.0.0.16 CIDR, and that's why, because you have given this in a properties files over here. Feel free to change it for your need. For a demo it works fine for me. Okay, so this is about VPC. Alright, now let's go to in fact let's go to subnets. Okay, and let's sort it by CIDR blocks. Now we see there are public private for 12.1 CIDR and another public and private for 12.2 CIDR. And 1A and 1B is nothing but I'm just spreading the availability zone and putting it over, so I'm aware which availability zone it is in without even looking into this. Anyways, okay, now you go to NAT gateways, and then you see that these are the 2 deleted, but when I run this script it has again created 2 NAT gateways. And finally let's see the internet gateway, and here you go. One internet gateway has been created to 29 VPC 29/29 VPC ID, and another one created as VPC ID ending with EA. So these are the 2 VPC. 29 belongs to 12.1 and EA belongs to 12.2. Alright, and then also let's see EC2 instances. So now I have 4 instances running, and you can relate over here why 4, because 1 in each subnet, and 2 in VPC1 and 2 in VPC2, each for public and private. Okay, so this is 12.1 blocks. This is public. Yes, this is a public subnet, so this must be in a private zone. So yeah, it belongs to private. So this guy, the last one and the first one, they both belong to VPC1, basically public and private here, and another one, this guy is in a public and 1B in private. Okay, belongs to 12.2. So perfect. Now what I'm gonna do here, okay, before that, the most important, let's also look the route tables, because this is doing the whole communication. So you can also see that peering connection. So a 1 peering connection has been created. So I just quickly run through a code. We'll not go into much details, but you see here I just created 2 modules, VPC base and EC2. They are like functions in Terraform, and using them you can basically create a VPC, and I'm just invoking it for my use case. So you see over here in the VPC1, I'm just invoke this module which creates a VPC1, and the same module is being invoked with a different and feeding different properties to create a VPC2. So this creates these 2 VPCs. Now EC2 instances. So in the VPC1 I'm creating 2 instances, the first one being public and private, and similar in VPC2 the 2 instances being created for public and private, right? And we can also see a VPC peering connection has been created, which says, like, you know, from VPC1 and VPC2 and auto accept. So basically if you manually create this VPC peering, it will ask for permission, but if you are using the same account and you provide this property, it won't ask for it, and silently it will accept that connection because it is in the same account. Anyways, alright, I think that's good. Let me also quickly show you the NAT gateways. There must be gateway, yeah. So here, this is in the function. It creates an internet gateway. Just creating a VPN gateway, not using it. So an NAT gateway, and internally it uses an IP address. All right, you just a small observation. So basically, as I said, like when you create an internet gateway, and you can see the positioning of this guy into this diagram. When you create an internet gateway, the only thing it needs a VPC, right? So basically, when you create an AWS internet gateway, and I given a name as my gateway, it needs VPC ID and doesn't need any other thing. However, when you create NAT gateway, and I have emphasized more on this must be created into a public subnet if you are intending that you associate to a route table, and these guys should be able to communicate to internet, and you're trying to associate this NAT gateway into a route table of a private subnet. This NAT gateway must be in a public subnet, right? So this is AWS NAT gateway, and you have to give the subnet ID, and 0 is public in my case. Alright, so this is a very basic about Terraform. Now let's do the final testing. I go to EC2, go to instances, pick up this particular instance, which is in a VPC1 and a public 1A. This is in VPC1 and this is in a public subnet. So we need this IP. Let's copy it, and you will also see that when Terraform scripts have been run, this has also been echoed over here. So ending with 250.36. Anyways, for now, I just want to SSH into EC2 of the VPC1 in a public subnet. Let's do that. So let me copy this. Okay. As well, you're inside the box, and you can validate the private IP 12.1.0.83, which matches with this. Alright, so now you're here. By the way, if you try to access directly to the private subnet, so basically in the 12.1, but in private subnet it won't allow, and this is the private IP address, but I have deliberately given a public IP, though it has a public IP address, but that does not mean you can SSH or go inside that. So let me also try that. Control R/I. So instead of the public IP address of a machine in a public subnet, I am giving the public IP address of a machine in a private subnet. So you just see I just pressed enter and it won't allow, it'll just hang and will time out after some time. So just minimize that window. Alright, so now I'm in this box. So basically you are here. Now what I'm going to do here is I'm going into this box because I want to ping a machine in a different VPC. Okay, so to go to this box, again I need to SSH and I need a key, which I have already, I'm using such an key pair too, as you have already seen over here. Okay, this one. Don't worry, I mean I will be deleting this key by the time I upload this video, so this is safe. Copy key.pem. Okay, save it, change permission, key.pem, and now I will be SSHing to this box. So let's get the IP address for this one. So 12.1.170, I'll be taking the private IP address. Again using the same command, so -i key.pem, I is like for an identity file, just get the pem file, CentOS @ and the private IP address. Perfect. Now it is SSHing to the second box. So now you see here it's like connection timeout, you cannot go from outside. Even if it is a public IP address, it doesn't matter, it is in a private subnet. Anyways, so now you can actually go to jump host or western host, and from there you can go into this machine. So that's why I'm here, and you can validate the private IP address must be 12.1.170. 12.1.170. Alright, so now we are here. Now only thing I want to do here is the ping to this machine. So I need to find out the private IP address of a machine in a private subnet of VPC2, and you can easily get it from here. So this is 12.2.1.107. I can ping from VPC1 to VPC2. Why is not working? Okay, let me try SSH over there. So I'll use the same key. Okay. Okay, let me key.pem OD 400 key.pem. Alright, so now what I'm going to do here is from this machine, from here, I will be SSHing to this box, which is in private subnet of a different VPC altogether. ssh-i is key of pam send to s @ and from 12.1 I'll be going to 12.2, and 12.2 IP private IP address is this guy. Yes, perfect. Now you can see the communication is properly stabilized. From this machine we are able to go into a different machine in a private subnet of a different VPC. And how this is happening? Because of the peering connection. Okay, and here if you are interested you can actually check the Terraform files. Okay, I think this I've already covered. This is like creating a VPC peering connection between two VPCs, but just creating a connection won't help it, because you just created this line of code, this piece of code what is highlighted will be creating this guy over here. This will be created, but eventually a route table, the route table must associate this guy, and this route table itself should be associated with a private subnet. So now if you see on here a route table in VPC1 to VPC2 communication, so basically get the route table and then associate it with a peering connection. All right, so let's actually validate it in the AWS itself, and this is the most critical and important piece over here. So let me sort it by VPC, and we see there are two VPCs with 12.1 ends with 29 and 12.2 ends with EA. So let's go to route table, go to subnet, and in the subnet we can see the subnet belongs to 12.1 public, so basically this guy, right? This is a public 1A, and this subnet 12.1 actually uses the route table which is just associating the internet gateway. So because only internet gateway is associated and the route table over here, all the communication, any communication which is not in this CIDR range should go to this internet gateway, and that's why your all traffic to and fro from this EC2 it can access internet. However, if we see same 12.1 the private route tables, here you see that it is connected with, for all local communication it will use this destination, but for all the connection like other than peering, I'll just quickly come to that. If you have to like cover 12.2, of course you have to use the peering connection. It's nothing but we have already seen, we'll click and see it later. But the most important thing for the NAT gateway is like anything like from this subnet, if you want to access anything you have to go via NAT gateway. So that's why once I am into this machine, so basically I'm here 12.2.107, basically this machine I should be able to ping google.com, right? If this NAT gateway is not in public subnet, or if this NAT gateway is not associated with this route table, this won't work. And I'm gonna quickly show it for peering connection at least over here. So I'll leave the peering connection as is, I'm not touching it, but in the route table for yeah, just forgot what is the VPC ID for 12.1. VPC ID was 29. Okay, so 29, this guy. So not the route table, so let's go subnet. I think that's easier. 12.1 private and go to route table. This is associated with this peering connection, and I'm gonna open it in a new tab, and this is the same peering connection. Let's disassociate that. So I'm gonna edit route table. So before that, let me exit. I came again to 12.1 and I can associate and go to 12.2, no problem. But if I disassociated this thing, subnet, okay, route tables, let me go to route table and routes, and actually edit routes. Yeah, here, and I'm gonna remove this, save changes. Now once this connection is cut, there is no way you can reach to VPC2 from VPC1. Let me try this, and now you see this times out. This will time out in some time. It's not SSHing to that box. Alright, that's pretty much for this thing. I hope this will help you to understand better about VPCs, connectivity between different VPCs, the role of internet gateway, and the role of NAT gateways and route tables. Alright, if you like this video, please like my video, and thanks for watching.